the purpose of the counting circuit is essentially, well, it's to count. This, as you can see down here, I've implemented a tens column to my counter. So the first step was the NAND gate oscillator. The second step, to be quite frank, I don't really remember the second step. The third step, however, was the decade counter. The fourth step was the binary counter. And then this last step before the actual IC is the real thing with a 7-segment display. So in effect, what's going on is the NAND gate oscillator is it's emitting square waves when this capacitor and this capacitor basically give on off signals very quickly, and then these gates, these ICs will then interpret them and then send them to this, the first digit column, and then down here is the tens column counter, and as you can see in the blue wire, it's jumping the divide by 10 pinout directly down here to count this. Now, it's obviously counting at 1/10 of the speed. And then, yeah, that's essentially how it works. These wires are just so that I can bring it to the next breadboard. If you ask, it's impossible on one breadboard, unfortunately. But I will make you go backwards real quick by flipping these two switches. All right. Now that the switches are flipped, you can see the circuit counting backwards. Implemented in this circuit are a variety of ICs, well, gates, including a 4011, 4017, 4510, and 4511. Now, the 4516 has been previously switched out by the 4510 due to the fact that the 4516 used in the binary up-down counter and the decade counter counts above 9, whereas this 4510 and this 4510 only count up to 9, and it enables it to kind of reset immediately, whereas you wouldn't have to kind of engineer that on your own with the 4516. So the 4516 on this display would actually go, it would blank. That's what would happen. But the 4510 enables us to just roll right over. If I wanted to, I could add a third column. In theory, you could add as many columns as you want, but really nobody wants to do that, and we understand how it works.